In this video, we're going to give a rough sketch of the following function, negative cosine of x plus pi by 3. What I'm going to do is I'm going to follow the 5 points from our original cosine function. The 5 points we all should know. 0, 1, pi by 2, 0, pi negative 1, 3 pi by 2, 0, and 2 pi 1. So let's take a look at our first step. As we move from cosine of x to cosine of x plus pi by 3, what we really have to do is we have to subtract pi by 3 from all of our x values. Subtracting pi by 3 from 0 will give us negative pi by 3. Subtracting pi by 3 from pi by 2 will give us pi by 6. Subtracting pi by 3 from pi will give us 2 pi by 3. And then 7 pi by 6 and 5 pi by 3 for our remaining 2 points. Next, let's deal with this reflection. This is going to be a reflection that affects all of the y values. So as I move from this column to this column, I'm going to multiply all of my y values by negative 1. And that's going to give us the following 5 points. Note that the only points that are really affected are ones containing either 1 or negative 1, because if we multiply 0 by negative 1, this is going to stay at 0. So if we want to plot this particular function f, we have 5 ordered pairs. We're going to do that on the next slide, and then just try to connect everything with a nice, smooth cosine curve. So here I've plotted our typical cosine curve from 0 to 2 pi. And I've marked off intervals of pi by 2 along the x-axis. What I'm going to do in blue is I'm going to plot those 5 points we found on the last slide, starting with negative pi by 3, negative 1. So it's going to be somewhere over here. Next we have pi by 6 and 0, which is maybe somewhere in here. Then we have 2 pi by 3 and positive 1, which will be somewhere over here. Next is 7 pi by 6 and 0. This is just a little bit bigger than pi, so that's somewhere over here. And then finally 5 pi by 3 and negative 1. So this is maybe somewhere over here. And we just want to connect all of these together with a nice, smooth, cosine-like curve. And we'll label that as f of x, and there's a rough sketch of negative cosine x plus pi by 3. Let's take a look at one more sketch of a cosine function. In this example, we're going to look at f of theta is equal to 1 minus 2 cosine of theta. So we're going to begin by considering the points on our normal cosine function, and those are given here. First, we're going to move from cosine of theta to negative 2 cosine of theta. So what is it that this negative 2 does to our original points? Well, this negative 2 represents a stretch in the y direction by a factor of 2, and then a reflection. And what we're going to do to accomplish both of those transformations is to multiply our y values by negative 2. Multiplying our y values by negative 2 is going to give us the following points. 0, negative 2, pi by 2, 0, pi 2, 3 pi by 2, 0, and 2 pi, negative 2. Our last step is to consider what happens as we move from the function negative 2 cos theta to 1 minus 2 cos theta. Well, what's actually happening here is a shift upwards in the y direction, and that's represented here by the number 1. So in order to move from our second column into our final column, we're going to add 1 to all of our y values. Adding 1 to all of our y values gives us the following 5 points. 0, negative 1, pi by 2, 1, pi 3, 3 pi by 2, 1, and 2 pi, negative 1. So let's go ahead and plot these 5 points to get our function 1 minus 2 cos theta. So here I've gone ahead and I've plotted our usual cosine function, cosine of theta, using our 5 standard points. Now let's use the 5 points we got from the third column on our previous slide to graph 1 minus 2 cos theta. Our first point is 0, negative 1, and that is here. And then we have pi by 2 and 1, which is here. And then we have pi and 3, which is going to be up here. And then 3 pi by 2 and 1 is here. And finally 2 pi negative 1 is here. And if we were to connect these together like so, we get 1 minus 2 cos theta.